Hey, Cookies. Hope everybody's having a great morning so far. I don't know about you guys, but I felt really bummed yesterday when I heard the news that the governor was going to be keeping schools closed until May 4th because I miss you. So today I wanted to spend a little bit of time talking about why that is. And I invited two special guests, one you know and one you don't know. It looks like one of them is here now waiting for us. I'm going to let him in. All right, well, while we're waiting for Mr. Hinkle, let me let you know a little bit about who he is. I told you guys that back in the day, before I became your teacher, I had a whole nother career where I sold medical devices and I wore a suit every day, and I know that you guys find that hard to believe, but it's true. And Mr. Hinkle is one of my colleagues. I haven't set eyes on you in 10 years, sir. How are you?
It's been a long time. How's it going?
Time. It's going really well.
Great.
I'm really glad you joined me because I was telling the kids, I was watching The Governor this evening and heard that school's going to be out till May 4th, and I'm really bummed. And I'm not really sure why we can't go back to school. And so I happen to be on professional networking website that you and I are both on. And I saw some data that your company put out that helped me understand a little bit. And I wondered if you could share it with me and share it with our kids.
I'd be happy to. Thanks for definitely reaching out. It was great to hear from you, and I'm happy to do this.
Thank you so much.
Of course.
So you work now for a company called Hinkle, which keeps track of the spread of infectious disease. Could you give us a little elevator pitch about that so the kids can understand?
Yeah, I'd happy to. So the company I work with, Kinsa Health, and what we do is we actually have a consumer product that we've been selling, a smart thermometer that connects to your smartphone. And the core reason people use this is not because you take a thermometer and it shows you your temperature on your phone. It's that most people who are using thermometers are generally parents of young kids. It just seems to happen that kids often get sick in the middle of the night. And when you're a new young parent, you often don't know, what am I supposed to do about this? So the thermometer is a companion to the smartphone app, which is really a great tool to help parents understand really what should I be doing when I get a temperature. Is this something serious and I need to go get some medical attention? Or is it something where we can manage this at home and we just need to pay attention to what's happening?
How does the app tell them that? Does it have to do with where there's outbreaks of different things?
Well, what it does is there's a couple components. So number one is that we take general guidance from really well-established medical centers like the Mayo Clinic in Minnesota, like the Cleveland Clinic in Ohio, and we provide guidance. So when a certain temperature presents with certain symptoms, sometimes that means you need to go get attention immediately. Sometimes when a certain temperature presents with other symptoms, that means you are probably okay taking some Tylenol and managing it at home and just watching things.
So that helps parents. So I want to get into in a moment into how this app and the data you collected can help answer the question about why we have to stay home. But I have my other guest waiting in my waiting room, and I'm going to invite her in. Here is a face that the kids will recognize. Hi, Miss Wright.
Hi, guys.
Can I introduce you to Mr. Hinkle? Mr. Hinkle, this is Miss Wright.
Hi, Miss
She's
Wright.
my colleague at school. Miss Wright, before we go on, I need to apologize to you because in a previous video, I called Mr. Rosano the coach with the most. But you know, we have to stroke his ego to keep him happy.
We do.
We do, but I just want you to know that I'm a huge fan of your coaching.
Oh, I'm a huge fan. Yeah. I'm a huge fan of yours too. Yeah. Yeah.
Thank you.
I've never. Okay, so you guys have to help me out because I've never done this before. So I'm like,
it's cool. Just hang with us. So Mr. Hinkle's just about to share he told us a little bit about what his company does and the data they collect. And so we're about to, because I told him I'm really bummed. I don't know about you. I miss the kids so much.
I do too. I do. I feel really bad. I'm like, oh, I want to see you guys. So I'm like, oh.
Right. But
yeah.
I know there's a good reason. I just need some help understanding it.
Yeah.
All right, Mr. Hinkle, help us understand.
All right. So let's do this. I'm going to share some images, and that will hopefully help with the whole storytelling component of this. And the first couple of images I want to show that are just going to set the frame for what we're actually dealing with here in the US. So the first image is, let me go to the full screen. So the first image we're looking at here, you guys can see that, I hope?
Yep, we sure can.
Okay, great. What this shows is on a logarithmic scale, how does the US compare to other countries that are dealing and have been dealing with this epidemic? So the key thing to know about a logarithmic scale is essentially you have the same distance between, between vertical indices, and so it's a power of 10 between your actual vertical lines. And so this is really powerful in that what this is showing is that the US is actually, in terms of the number of cases that we're dealing with, from the moment we had our 100th case, we are actually in probably the worst position of all the other countries that have dealt with this issue. So this gives you a sense for the seriousness of the problem.
It does. I have a couple. Well, first thing, you're using words like logarithm and exponential that I remember sitting in math class in 8th grade, scowling at my teacher saying, I'm never going to need to use these words. And here we are in this moment, and I'm looking at this graph. Can you just really quickly tell us, like, what's on the x-axis, what's on the y-axis?
Sure thing, no problem. So on our x-axis, you have the number of days since the 100th case was identified in each of these countries. Okay. On the y-axis are the number of actual cases identified. Okay. So when I mentioned that the distance between your vertical values is the same, what you want to look for is the powers of 10, because we're dealing with exponents here. So we start at the baseline where at 0 days, after the 100th case has been identified, we have 100 on our y-axis and 0 on the x-axis.
Got it.
Okay. So the next power of 10 up takes us to 1,000, and we have a couple of other numbers in there that are filling in the gaps, but you see the jump up from 100 to 1,000. If you then take a look at the next level up, you see from 1,000 to 10,000, you've got the same amount of distance there, even though the number of cases is actually 9,000 additional cases in that same vertical distance.
Okay.
Okay, so does that make sense?
It does, and it really helps to understand that this is kind of a for real thing.
It is. And to give you guys some reference that's not on this chart, the range at what the US is in right now means that the number of cases is doubling in about 2 to 3 days. So if this pattern holds, that means by Saturday, we're going to see numbers over 100,000.
Wow.
So is there even a point to stay home?
Well, there is, and we can certainly get to that.
All right.
For something that's a little bit more visually dramatic, I want to at least share this with everybody. So we look at our typical scale of the number. So these are the same exact data points, but instead of having a logarithmic scale on the y-axis, here we have a linear scale. So instead of the distance between the y-axis points being exponential, what we have is that they actually are in sequence. So you can see we go from 0 to 10,000 to 20 to 30. And again, you can see the position that the United States is in. And the important thing here, of course, is to notice the steepness of the curve. So this gives you a sense for the magnitude of the issue we're dealing with.
Yeah. Before you go forward, Mr. Hinkle, Miss Wright, this looks like a lot of the stuff that the 8th graders are doing in math with rise and run. Can you maybe put that into a little bit of context?
So actually, if we could go back to the first one, I was thinking, so we're doing, you know, our linear equations and things like that. So I was noticing here that some of the kids might be able to identify this right here, where the x is 0 and y is at 100. So hopefully, fingers crossed, they would notice that would be the y-intercept. So that would be when x is 0 and y, whatever y is. So if it say it started here, then your y value would be 500. So your y-intercept would be 500. On the next chart that we had, or the bar graph. This is more of our linear equations that we've been doing.
Yeah, that's what I was
So,
thinking.
yeah, so they would be able to see that when you're down here with the 0 and the 5, and when your x is in the single digits, it tends to have a more, not as a steep slope. So if you look here, this pretty much has no slope until we get up into, I don't know, about 5, 6, 7. Our slope is very small because you're going from the rise to the run, and then all of a sudden it jumps significantly. So they should be able to identify that with what we have been looking at. So they would, yeah, let's hope. Fingers crossed.
I know they can. Our kids are pretty sharp.
I know.
They are.
In a few weeks, but we've been doing this for a long time.
Mm-hmm.
I was just curious, and I don't know if we had any kind of, when you said logarithm, someone had asked me about the fact of kind of, is there any way kind of to make a prediction as based on the data? Is there anything that we can predict, like you had said, by Saturday? Is that how you're using to make your prediction? Are you using these charts or these numbers? Could you kind of talk a little bit about that?
Yeah, so that's exactly where that prediction comes from, is just understanding the range at which, not only what the numbers are, but the rate at which they're increasing. Then that is when you're able to project out what is the number or the value going to be a certain number of days from now. So if we look on this chart here, we can see right now, the current day, we're at about 52,000. You can see that yesterday we were at about 42,000. The day before that, 32,000. So at that point, just with doing some rough regular math, I mean, we're just doing addition right there. If that rate of change remains constant and we have what is mostly a vertical line, you're just going to be adding another 70,000 to the 52,000, and clearly at that point you're already up over 120,000 cases.
Right. There's that word, that vocabulary, constant rate of change. We've been doing so much about, yeah. So it's crazy. I love how we can actually put this into perspective, because you hear all the time, I'm never going to use this, I'm never going to use it. So I think this is, unfortunately, the situation isn't awesome, but having like this kind of visual for everybody is just,
and having the skill to understand the visual, right? I think that's the thing that the kids can feel good about, that they can access this information and understand it because they've been working so hard.
Right. Well, and it's funny because one of the things that I would.
Oh, lost you, Miss Wright. Okay, Mr. Hinkle, we're going to keep going because I think we lost Miss Wright a little bit there. She'll come back.
Okay. So the next thing I want to do is I want to go back actually to a little bit of where we started, which is talking about the thermometers. And just to give some people, beyond what does a parent do when they take a temperature, how does this actually turn into something where I'm working with a company that can actually predict what's going to happen as well?
Yeah, it's wild.
So the key thing to understand is that, not that we have 5 or 10 of these that are out there being used by families, but we actually have over 1 million thermometers across the country. And people have profiles in their app, and we have about 2 profiles per thermometer. So we have about 2 million people who are putting data into the system. And while they are, of course, getting their information when they take a temperature, that information is also coming to us, okay?
Yeah.
And so what we can do with that, you asked the question really early on, Ms. Pav, which is, well, do you give information about what's happening around them? And that's exactly the thing that we also do, is we can tell somebody if they're taking a temperature and they have a fever of 101, they are at a higher risk if they are in San Francisco and the other people around them also have fevers, compared to if they have 101 fever and they live in Detroit and the people in Detroit just don't have fevers around them. So that helps us, again, give them some guidance as to how much of a risk this fever actually poses to them. So
what's cool is I know that the kids did like a mini unit on statistics. And so when you talk about your 2 million users of your app, like that speaks to sample size and the validity of the data. and how meaningful the data is, because you just have so many people participating.
That's right. That's exactly right.
Is that app able to tell you the ages of people, to give any kind of data on kind of the age ranges of people?
Yeah, so when people create their profile, so if I were to create a profile for myself, for my wife, and for my daughter, we would go ahead and we would enter our names and we'd enter our age into the app. So if I take a temperature for myself and I record it under my profile, it knows that it's a 48-year-old person, male, who has taken a temperature. And if my daughter's the one who's sick and we take her temperature, it knows that we have an 11-year-old who is the one who has recorded a temperature. And that's actually important for other reasons. You guys can imagine that one of the things we can learn is that if my daughter gets sick and then she recovers and she goes back onto her daily life, that tells one story. Whereas if my daughter gets sick and then I get sick and then my wife gets sick, that tells a very different story about the type of severity we're dealing with in an illness.
Exactly. It's also interesting I don't know if you use that for if you even have it, you could make another visual or a graph where they could have using the age ranges as one of the axes.
So many different ways to show the data.
Yeah, there's so many different
We have a lot of data flying around our company. There's no question about that.
I'm sure. That's crazy.
But let me show you one of the cool things that we've done recently, which is really relevant to the story about what are we doing now and why do we have to be careful, and why is it an important thing that actually we're all going to be unfortunately separated from each other with the schools being closed. So one of the things that we have done recently is we released a map. So we're looking at a different kind of data visualization now. We're not looking at a chart, but we're looking at a map now of the United States. This is current as of today. And this one's a little more complex. So let me describe what we're looking at. So you see the scale up at the top, or the legend, where it goes from not applicable to none, low, mild, moderate, and severe. And what those tell you is this is a map of the US that's showing our forecasted illness in each of these geographies. So because of those million thermometers that are out there, we have a pretty good idea of, as of the end of March, what should the fever temperature, or what should the amounts of people with fevers be in Boston? What should the amounts of people with fevers be in Florida? What should the amounts of fevers be with people who live in Arizona? What should those be? Well, the interesting thing is that with a huge issue like COVID-19 and a big virus spreading around, we're actually picking up significantly anomalous readings in many of the different parts of the country, okay?
Vocab word.
Yeah.
Anomalous. All right. So I got to tell you, my kids are vocab ninjas. So one of the strategies that we would use here would maybe be word replacement. Like, what word could we put in the place of anomalous? And I'm thinking unusual, maybe. What do you can you help us understand that word, Mr. Hinkle?
I think unusual would be a good fit. An anomaly really is something that is out of the ordinary. Mm-hmm. So we have made predictions, again, based on certain readings, and an anomaly is something that is outside the range of those predictions. Mm-hmm. And you're actually leading me perfectly to the next slide. So what we can see is an area down in Florida, which this stands out because it's a different color, right? We can see that there's a lot of activity in Florida. And it's a little bit of a more concerning color here. I see the moderate and even some of the high atypical levels. Right, that's right. So if we were to zoom in there, here's what we actually see. And I've just clicked on the St. Lucie County in Florida. And this is getting to the story about why we need to worry about staying apart from each other. So in this county, what we see in that chart at the bottom, that's where it's really important. So our y-axis there is the percent ILI, and ILI stands for influenza-like illness, okay? The x-axis is a date range. We see February 15th is our home point, and then May 24th is the end of the chart at this point. Now, what you see are a couple of different colors. Number one, you're seeing individual daily points, which are connected in this instance by an orange and a red line, depending on where they are on the chart. The other thing you're seeing is a dotted blue line highlighted or shaded above and below with a lighter blue color. Yep. So what we're looking at is, again, based on modeling that we have done from all of our historical data, we understand what should the expected number of influenza-like illness incidents be in St. Lucie County, Florida. So that blue dotted line is the expected line. The typical range is that blue shaded area. And what we're actually seeing is that the number, or the percentage of people with influenza-like illness is much higher than the expected range. So that visually is an anomaly. Exactly.
So that's when everyone says, oh, it's just a flu. It's just a flu. This is your blue line is your just the flu.
I thought it was just the flu at first.
Yeah, I'm with.
Yeah, that's exactly right. So the blue line, there are people who are getting the flu down in St. Lucie, Florida. There's no question, because it's still illness season. It's very low, right? You can see that's around 2%. But the problem is that as of a couple of days ago, we were showing almost 8% people, which is 4 times what would actually be expected for this time of year in that area.
Wow.
Okay.
Thank you.
Now, the good news, the fun part of this story, hopefully, is
fun.
Well, what
I'm not feeling it, Mr. Hinkle.
But tell me, what direction do you see the ILI percentage trending at this point?
Yeah.
Look at that, and it's kind of a steep slope again, right?
It is, exactly.
Mm-hmm.
And so that gets me to maybe the part of data that's really telling a strong story here. So
yeah, this is what I saw that made me want to talk to you.
Yeah, exactly. So here what we've done, we have another visualization, right? This is a line chart where we have plotted Santa Clara County's ILI percentage. Again, your y-axis is ILI percentage, and then the x-axis, we're showing a date range. So we've plotted the influenza-like illness percent in Santa Clara County, California, against the influenza-like illness percentage in Miami-Dade, Florida.
Okay, so we have 2 cities.
Correct.
And we're kind of comparing them in the same graph.
Correct.
All right.
Exactly
Percent
right.
of influenza-like illness over time. Gotcha.
Yep.
And is
So,
this the percentage of all of the, based on the population of the city?
this is based on the population of the regions and the number of thermometers. We obviously don't have a thermometer in every home here, but
A
again,
big sample size.
as Ms. Pav mentioned earlier, we have an appropriate sample size to make this projection.
Awesome. Right.
And so if you remember the last slide, we showed that the expected ILI percentage in the Florida area should be about 2 to 3%. And you can see at the beginning of March, that's exactly what we saw. Okay. It was a bit higher in Santa Clara County, and they were already experiencing some elevated anomalous readings. And so you can see from the indicators along those lines that the actual federal or the local government started taking some actions. So February
choices that the local governments are making in these pockets.
Right. So February 10th, they declared a state of emergency. On March 5th, they issued work from home guidance. On March 9th, they restricted public gatherings. And if you follow that blue line from left to right, they closed the schools on March 16th. On March 17th, the shelter in order place. And pretty quickly after these measures occurred, you started to see the influenza-like illness percentage drop fairly dramatically. Okay? Now, unfortunately, that's the opposite of what we saw happening in Florida. If you guys saw the pictures of the people that were on the beaches, and what we ended up seeing is that normal level at the beginning of March, as we progressed forward, really started to increase. So on March 12th, they declared a state of emergency, closed the schools on March 16th. But at that point, all of those people had already been around each other, had already been either asymptomatically or perhaps with some symptoms. They already had been contaminating each other. And so that's why we see one geography going in one direction, because they started these measures, and the other geography essentially did the opposite. And so we see the chart going in the opposite direction.
What strikes me here is how much every day matters.
Oh, it's crazy. We actually were down, my parents are down in Florida, and it's crazy that there are still people that are on the beaches and acting as if, and where they were, they did close down the public beaches, but it's amazing. And and what makes me even more concerned about it is the age range of the people that live in Florida.
They're
I mean,
older
when you
people.
think about who's most susceptible to this, it's an anomaly, I guess you would.
Well, I'm thinking about, our friend Mr. Rosano in civics class, and I do think that, the idea of being a member of a community and having a civic responsibility kind of comes into play here as well, because these orders are in place, but people have freedom up to follow orders or not. There's going to be consequences, but this is a case where the consequences don't just affect you.
No, and that was one of the things that we were struggling with, is that you had, especially with the time of year, you had a lot of spring breakers, and I think it was tough for them to say, they were young, and they were saying it doesn't matter, and I'm young, I'm not going to get it. So it's very, I love to see this though, when you look at the after the 18th, when they actually got the bars and the restaurants closed, I'd love to see that decline. And like you said, it's pretty steep.
I love how the exact math skills our kids are using can help us get our heads around this. And I think that, in ELA, we're talking about how to make persuasive arguments. And one of the key components of a persuasive argument or rhetoric is logos, which is information, data, statistics, and how important that is and how credible that is in helping us make our decisions. So like when you get to the end of the paper or you get to the end of the argument, I always tell the kids there's the so what. Like, what is the takeaway? And I think we're kind of getting to that point here. So we see these other cities, Mr. Hinkle, so what? What do we conclude for us in Fitchburg, North Central Massachusetts?
Yeah, I mean, I think the key takeaway here is that these actions that we're taking, they matter. They make a difference. They actually do stop spread of illness. If you are interacting with fewer people, you're going to infect fewer people as somebody who may have a virus around you. And that's really what it's going to take for us to successfully manage this incident that we're dealing with, is to prevent infecting others who may or may not go on to infect people like you're talking about, who are in a much higher risk category. But this really is the critical thing to make sure that we can get a handle on this.
Yeah. Speaking of anomalies, has anyone done any data on West Virginia and why there is nothing happening there as far as this virus?
I've been to West Virginia on sales calls, and the population is a little bit more. There's not as much, like, they're not packed in like we are here. It's actually beautiful. You can see the stars.
It's just funny. They're the only state, just for now, but that's just,
for now. All right. Mr. Hinkle, do you have any other data or any other conclusions that you want to share with us before we let you go?
This is what I brought. So hopefully it's been helpful. It's been really a pleasure. I really thank you for the opportunity. I hope I know it's hard. It's hard for us. I know it's hard for everybody that is probably going to watch this, but I really hope this helps bring it home that these actions do make a difference. And the problem is extremely serious for everyone. And so hopefully this, again, does make a difference for people.
It does. And I think, to me, there's the message that this is serious that I want the kids to understand, but also that we're doing things that are going to keep us safe. So, we can kind of measure our anxiety around it when we look at that drop in the curve, and maybe feel like we're doing the right things and that we're going to come out of this okay. And boy, we have skills that are going to help us not only understand the world around us, but get a great job someday at a company like Kinza. I'll be writing recommendation letters for my 8th graders in about 10 years for you, Mr. Hinkle.
That sounds good.
Yeah, we have some good ones.
Excellent. I love it. All
right. Well, thank you very much. 8th graders, I hope you enjoyed this. I know it was a lot of information, but I wanted to show you and show myself that we're doing the right things. And thank you for all your hard work. continuing to
Yeah,
sign
that
into
was
Google
great.
Classroom and staying at home. And we miss you, right, Miss Wright?
Oh my gosh, I miss you. I made you guys a video. Um, if you guys want to email, just on the side, I'm making an 8th grade classroom for all the 8th graders. So if you want to email me, I'll add you to that. So
Well, thank you.
I'll shout out to that.
Mr. Hinkle, thank you for your valuable time. I'll let you get back to your family.
It's my pleasure. Thank you very much.
It's nice to meet you.
Great
Bye,
to meet you
everybody.
as well. Bye.
Bye, guys.